Hey TechKnowStuds, let's do a quick review of what a standard access list is, and then we're going to, in the next videos, actually implement it with some demos. In this video, we'll start out by talking about that standard access list and what it looks like. We'll get into the placement of that access list, and then we'll wrap it up by talking about the wildcard mask. The standard access list is really quite simplistic. First of all, this is a numbered access list, and I can see that it is a numbered list by the numbers here. And so this access list is number 42. Each of the access control entries here are grouped up together because of the 42. That's what tells it that it's part of this number 42 access list. The number 42 also says that this is a standard list. If it's between 1 and 99 and 1300 and 1999, that's what defines the range for a standard access list. So what is a standard access list? Well, all of this information at the end here are source IP addresses. So it takes a look at the packet and looks at the source IP address, and that's how it determines what it's matching against. All right, so the first one here is a host, and you can type out host and then the IP address, or you could exclude host and put in the wildcard mask of 0.0.0. Either would work for that right there. So what it's doing is this is denying this host right here. And then it permits everything else from that same network that that host is on. Then it denies that site right there, and then it permits everything from all the other sites is what's happening here. So, and once again, what's going to happen is that packet's going to come in, it's going to take a look at that source IP address and try to match against each one of these and do that permit or deny. And then there's that implicit, that unwritten deny all at the end of these access control lists that stop all other traffic if it doesn't match against anything. And you got to be careful of that, because if you apply an access list to an interface that doesn't have all your permit statements in it yet, then you're going to be blocking all of that traffic. So just be conscious of that. There is also a named access list, and we'll get more into that into one of our demos, but you can name an access list, and this can be really handy, naming an access list, because that name can actually tell you what the function of the access list is trying to accomplish. So you can incorporate that into the name, so that's nice. And although we would like to create efficiency with this by putting this close to the source of the traffic, the problem is that could block too much traffic. So an example of this is, let's say I'm trying to block this demo laptop from reaching this network over here. If I were to put it over here on switch 1, where it would be very efficient because it would block all the traffic from being processed along the way. The problem with that is it would block demo laptop from getting to any of these devices, because it's just flat out blocking the source, which is this demo laptop. So what we'd want to do in this case is we'd want to put it closer to the final destination. So when it comes to standard access lists, put them closer to the final destination. And so that's the general rule when it comes to standard access lists. Now, when it comes to wildcard masks, I'm not going to get really in depth into this because I already have another video that covers specifically wildcard masks. So you can go back to the OSPF lessons and it's in there. But wildcard masks essentially is often the reverse of whatever the subnet mask would be. So a subnet mask has all ones that denote or that flag what are the network bits. Well, wildcard masks, the ones define the bits that we don't care about, that are wildcards, that could vary, that could be different. So if we have all zeros, that means that none of the bits can change. None of the bits, they all have to be exactly the same and match, and so that's going to match the host. If it was all ones, that means that it will match everything. We can also create networks. If we create a network, like in this case right here, this is a /24 network, and so we're just matching the network portion of this, and the host bits we're not matching against. So the one is the wildcard part of that those are the ones that we don't care as much about. And then I've got in here also a summary route with it that would be extend beyond what a classful address would necessarily be, or whatever your subnets, how they're divided. So these are wildcard masks, and you would create a wildcard mask that would, so it could match the traffic that you're really trying to hone in on, that you're really trying to match against. So the standard access control list is what we're going to start out by doing the demos on. They're the more simplistic of the two, and so we will be applying that onto our network and seeing how it interacts. And then we'll also, as we do that, we'll have to place it on the interface as well. So we'll create the access control list, and then we'll place it on the interface. And then we wrapped up by talking about the wildcard mask, because you're going to use wildcard masks to match the different networks and match the different source IP addresses that you're trying to match against. So there you have it, standard access list. Let's get into some demos.